All right. One might wonder why a red elk is dropping from a cliff. And the answer is that red elk was a student of mine back at Breck School. Um, and he was a diver, actually. But he's just going to drop from this cliff, right? But there's water down below, so we're not killing red elk. He was just an ordinary child with an extraordinary name. All right. So there he is. Has no antlers or anything like that, right? So don't be drawing antlers and stuff on him. Okay, so this is 11.2 meters, right? And we are just going from here to the water, right? Okay, so here we go. Let's go from the top to the water. X, VI, VF, A, and T. Okay. Now this is tricky, right? Our displacement is actually down 11.2, okay? So that negative is because it's down, right? That's meters. So don't forget the negative sign there, okay? Because you'll get in trouble if you don't put the negative sign. Our initial velocity is, since he drops, he's not jumping up or jumping down or something like that, right? His initial velocity is 0, and then our acceleration is negative 9.8, right? Okay, so for these ones where we fall into the water, our initial velocity is just 0. Okay. I think what I'll do is I'll use no t to find VF. Okay. So final velocity. No, it's really slow. Okay. VF, the pen is slowing down. VI plus AT. All right. Okay, so final velocity is, we can't do that. Can't use that one. What am I doing? I got to use this guy. VF squared is VI squared plus. So you just zone out a little bit and you get in trouble, right? Got to use that guy, right? Okay, so we're going to use no t to find that. Uh-oh. All right, so final velocity squared is 0 squared plus 2 times negative 9.8. And here's where the minus sign, you have to have the minus sign, negative 11.2. Now we've got a positive number here, and we can take the square root of it, okay? All right, are you ready for this? So 2 times negative 9.8 times negative 11.2. This is VF squared, ends up being 219.52. And then I'm going to square root both sides, so raised to the 0.5. And you end up with 14.8. Now this is the absolute value of VF, right? It's 14.8. Okay, but the answer is that it actually strikes the water with a velocity of negative 14.8 meters per second. Okay, now the reason is that, of course, if the absolute value is 14.8, that means that your final velocity could be 14.8 or negative 14.8, right? If you square both of those, you'll get 219.52. Right? Negative numbers squared are positive, right? So when you take the square root of a square, consider the possibility that it could be negative, and don't forget to put that negative sign on there. Okay, so the answer that's down here actually was wrong. Okay, the answer is that it's negative 14.8, and the answer is that the reason that it's that is that red elk has lost his antlers now, and he's moving down. He's going down when he strikes the water. Down is a negative velocity. Okay. Now, time to hit the water. I think what I'm going to do is I'm going to use, now that I have the final velocity, I'm going to use this guy. VF is VI plus AT. So final velocity is negative 14.816. So I'm using a few more digits here, as you should as well. That equals 0 plus negative 9.8 times t. So we can solve for t now. So this is 1.511. So t that's what time it takes to hit the water. That's pretty tall. That's like 11.2 meters times 3.281. That's the conversion to feet. That's 36 feet. I mean, that's a really tall cliff. I mean, I know people jump from taller ones, but people braver than me, right? I've probably jumped off of something that tall, but maybe not much taller. All right. Okay, so This one, basically the only power tip we used was the acceleration of gravity was negative 9.8. And then we also solved for a final velocity, and we chose the negative answer, okay, because it's going down. That thing, the minus sign, is going down. And you won't get all the points on your test if you tell me that it's a positive 14.6. It would be interesting to strike the water at a velocity of positive 14.8 or whatever, right? Like you're coming up out of the water. All right.